Hello everyone. We all are so much frustrated with this current scenario of pandemic. So let's focus ourselves somewhere where it's gonna really blow our mind. The universe. The universe is full of surprises and mystery. When we talk about universe, our mind thinks of things like galaxies, stars, constellations, planets, asteroids, black holes, gases, stardust, supernova, Big Bang, particles, etc. etc. Before getting into the core, let me remind you how small we are in this universe. We live on a planet called Earth, as you all know, and this Earth is located in solar system, and the solar system is located in Milky Way galaxy. Let me tell you how big our Milky Way galaxy is. The diameter of our Milky Way galaxy is 1,05,700 light years. What is light year? If light travels for 1 year in any direction, that particular distance is 1 light year. To tell you in kilometers, 1 light year is approximately 9.46 trillion kilometers, and 1 trillion kilometer is 1 lakh crore kilometers. You do the math. So just our Milky Way galaxy is this big. Imagine how many other planets are in Milky Way galaxy, and imagine how many other galaxies are there. And there are galaxies which are far bigger than Milky Way. Imagine how many other planets like Earth might be in some other galaxy, and how many more solar systems in any other galaxy, or even in our own Milky Way galaxy. So the universe is that big, and still we don't even know how many number of galaxies are there or how many number of planets are there. But what if I tell you that you, me, our Earth, the solar system, the billions of stars, planets and galaxies, and even what all are in it, just makes 4.9% of the universe. So if all these combined is just 5%, so what is the rest of the 95%? So in the remaining 95%, 27% is consist of dark matter. So if you don't know what is dark matter, let me brief you what we know so far. We know that it exists. That's all. Because we don't even know how it is, where it is, and what it's made up of. Then how do we know that it exists, and why it is very important to know about this? According to laws of gravity, which was given by the geniuses Johannes Kepler and Isaac Newton, if something has more mass, it will have more attraction, which means more gravity. If we apply this particular laws of gravity to our planets, let's take few examples from our solar system itself. The largest planet in our solar system is Jupiter, and the smallest planet in our solar system is Mercury. As we know, by laws of gravity, more mass means more attraction, means more gravity. So Mercury has the least gravity and Jupiter has the most gravity in our solar system. For example, if you weigh 100 kilograms on Earth, you will weigh just 37 kilograms on Mercury. The same 100 kg will weigh 252 kilograms in Jupiter. This is because Jupiter has more mass and has more gravity. Mercury has less mass and has less gravity. And this mass not only affects the gravity, it also affects the rotational speed of any planets or any body. I'll give you one more example for gravity. As we know, our own satellite, which is Moon, is a smaller planet. The lesser the mass, the lesser the gravity. The same 100 kilo on Moon will be just 16 kilograms. So as I said, more mass, more gravity, and more rotational speed. For example, Mercury, which is the smallest in our solar system, rotates at the speed of 11 kilometers per hour. If we compare Mercury to Earth, Earth rotates 1674 kilometers per hour. And if we take a look at Jupiter, which is the biggest in our solar system, the rotational speed of Jupiter is 45,583 kilometers per hour. So where am I going with this? So more mass, more gravity, and more rotational speed. We have found out that our whole universe is rotating, and it is rotating 400 times faster than the accounted mass it has, which means all the stars, galaxies, etc. etc. How is this possible? Let me give you one more example. If our Earth rotates as fast as Jupiter, the sun can't hold it. Our Earth will be out of the orbital plane and it will be somewhere in our galaxy or even at the end of the universe. So if it is rotating that faster, whatever is holding it in the orbital plane must have that much of gravity. We discovered something makes this much of gravity not only makes the universe spins faster, but also holding it all together with the power of its gravity. Or else in this speed, all the stars, planets and galaxies will be scattered around the universe. What is it that is making this much of gravity? What is it that is having this much of mass? It's called dark matter, which is 27% of universe. So what is holding up the entire universe without scattering? That is dark matter. Let's see some other evidences how we derive that dark matter exists. Number one is gravitational lensing. What is gravitational lensing? As we saw, the bigger the mass, the more the gravity. So, the more the gravity, it will bend the light rays. As you can see on the screen, this is called gravitational lensing. In an easy way to understand this, if there is a star in front of you and there is one more star right behind the star, you can see the star behind the first star without even changing the angle. This because the gravitational field on the first star bending the rays, and we can able to see the second star which is right behind it. This phenomenon is called gravitational lensing. And number two is relic radiation. In other words, CMBR, which is cosmic microwave background radiation. What you are seeing on the screen is the CMBR image, which shows that our universe is nothing without dark matter. What is this CMBR? In simple words, it's an image of our universe many billion years ago. How is this possible? How can we take an image of our universe many billion years ago? This is because the delay of the light travels. For example, if you see a star and that particular star is 10 light years away from you, even if the star exploded, it will take another 10 years for us to see that the star has exploded. So that's how we look into the past of our universe using this microwave radiation and made an image analysis. This is by far the most provable evidence for dark matter. And number three is galaxy clusters. Why and how so many groups of galaxies are in a cluster without scattering apart? What is holding those many galaxies in a place? There are few other perspectives also the scientists are looking forward. For example, WIMPs, weakly interactive massive particles. To say in a simple manner, it is very powerful, but it won't interact with us, or we don't even know whether it is interacting with us. For example, in our elementary particles, there are neutrinos, solar neutrinos, which is coming from sun. It doesn't even interact with us. There are other neutrinos which comes from particle decay. Even those doesn't interact with us. So there are least possibilities that it belongs to the WIMP family also, which is weakly interactive massive particles. So what is this dark matter? Is it antimatter? To put in a layman term, antimatter is a particle acts like electrons but positively charged, and acts like proton but negatively charged. Usually it's the other way, because electrons are negatively charged and protons are positively charged. But even antimatter reacts with particles and other protons and electrons, but dark matter doesn't. So far we don't know what is dark matter is, but we know what our isn't. So there are so many scientific research laboratories around the world trying to study this dark matter. One important lab, which is located in South Dakota of USA, located 1.5 kilometers underground. It's called LUX, not the soap. Large Underground Xenon Atom Experiment. And how this is useful in studying dark matter. Dark matter is everywhere. It is even around me. It is even around you. It might even passing through us, passing through our earth daily. But we can't see it, it doesn't react with us, or we don't know how it is reacting with us. So to be away from other interferences like cosmic rays, other neutrinos, this lab is located so deep away from all these kind of interferences in a huge water tank, which is highly purified water, and inside that there is a pack of xenon atoms. If in case a dark matter passes through it, it will react to the xenon atom and it will emit the electron. That is of course a theory. Till now we couldn't find anything. There is one more lab in Canada which is Snow Lab, and that is 2 kilometers underground, and they are using the same method as in Lux laboratory, but they are using argon atom. With years and years of this research and experiment, they couldn't find anything. So scientists are looking out for some other answers as well. At Switzerland, there is an organization called European Organization for Nuclear Research, in short CERN. They have the world's biggest particle collider. In this laboratory, they are trying to catch or create dark matter. How they are doing it, or how they are trying it, it's by colliding particles. It is done by a beam of protons going in one direction and another beam of protons going in opposite direction with 4 junction points, and at this junction points both the beam collides and you have an explosion, and a mess of particles comes out of this collision. So scientists are trying to see and identify what are these particles, or is any one of them is dark matter. And this is how they create new elements, by colliding the particles. I think you would have seen this in Iron Man, but still they couldn't find anything. Some scientists are saying that dark matter is another form of gravity, but they don't know where the origin is. Actually, we don't even know our Earth gravitational force also. Obviously, we know that the gravitational force is keeping us to the ground, but other than that, in a molecular level, we don't even understand our own Earth's gravitational force. And some scientists are trying to observe it in space by using space vehicles. Even by doing all these, the answer we get is 0. The interesting thing about dark matter is how it is defying all the laws of physics as we know, but present everywhere, passing through us, passing through all the planets, but our knowledge doesn't understand how this is even reacting. Actually, the dark matter doesn't react with itself also. Confusing, right? But still, it keeps the whole universe attracted to itself and spinning it. You can ask a question, why should I know about it? Why should anyone have to bother about it? In the year 1897, when J.J. Thomson discovered electrons, no one cared about it. But now, the whole world is reaping its benefits to our communications, our cell phones, all the electronic devices, the particle accelerator which is used to discover new elements, even in radiation cancer therapy. Any kind of invention or discovery is taking our lives one step better. If we understand this dark matter, who knows, we can use it for unlimited energy. Of course, the 90% of the world's problem will be solved if we get an unlimited sustainable energy. We may even cure diseases by manipulating it. So far, what we know about dark matter is one thing, that it exists. And what we don't know about dark matter is a million things. And finally, this dark matter is accountable for 27% of mass in the universe. And what is the remaining 68%? That is even more confusing and even more complicating. We will see about it in my next video. These reminding us that known is a drop and unknown is a